Oh my God.
Don't even do it. Don't do it. I already know what you're going to do.
For standard deviation, it would be 2 minus 5, and then you would do square root.
So it looks a lot like Pythagorean theorem, where you're going to have something squared plus something squared, square root of all that.
6 squared minus 5 squared, and then the square root of that.
I just sit there and we talk.
Do we just leave it in terms of a negative number, the root, or do you want us to, do we leave the root as a negative?
You can leave the root. Well, it shouldn't be a negative inside. Because it's all addition and it's there's squares.
Alright.
Yeah, that's what I meant.
Santos. Alright, so good morning. Happy Friday. So we're going to go ahead and get started here. Alright, so just moving forward. So this is what we focused on a lot yesterday. We're trying to find the expected value, the mean. So if we take two values, two random variables, if we subtract all their corresponding points, and we want to find the mean, what's an easier way to do that instead of just doing the subtraction first? How can we use the table to get some answers?
You plug in the values.
Okay, so what values are we going to plug in?
10 for x, and then 20 for y.
Okay, 10 for x, and then 20 for y. So we're just applying this rule. So most of you guys are just going to take 10 minus 20, but just know that you are using this rule here. And we had a really good question. Is it okay to have negative numbers? Well, in this case, we don't have a context. This is just giving you a table. We don't know what this is supposed to represent. If this is something like money, then maybe that's not okay. All right, so how about for standard deviation? Expected value is pretty much to the point. If you have subtraction, you take it out of the parentheses. And multiplication, you take it out. Addition, you take it out. But how about standard deviation? What are we going to do here?
It's a square.
We're going to use a square root. Square root of what? Something squared plus something squared. So what's going to go here? What are we squaring?
2 squared.
2 squared, 5. 5 squared.
So we changed the symbol from a minus to a plus?
Yes, it's always going to be a plus. And what do these represent? Again, we didn't use the equation, but the equation that we used was standard deviation of x squared plus standard deviation of y squared. And we take the square root of all of that. So we have this equation in our notes. You have it in your notes. Here again, if you want to write it down here first and then plug in, that's okay. If you just know what to plug in, that's fine as well. So as long as you can apply the rule, that's what I'm more concerned about. But just know that when things get a little bit more complicated, you're going to have to do this first. You can't just go straight into it. All right, so for today we're going to get into, we have one example left in your notes. We'll do some quizzes, and we'll get into some practice here. Yes.
Is it okay if we simplify it further if we want to? Like if I want to do 4 plus 25.
Oh yeah. I just stopped here because from there you guys should be okay.
Alright.
Alright, so let's go ahead and have out our notes. Again, we have one example that we'll get to. Just have out your notes, please. So we're now on the last example. We did this first example on the, the first example on the last page. We did that yesterday, and I also sent it to you on Remind, just in case it wasn't so clear yesterday. It just wrote it all, I wrote it all out, a little bit nicer, so it's also there. But we're gonna move on to this example. So before we get started, take a moment to read it, just so you know what's given to you. Maybe you're given some values, maybe we can use them. And also the situation's a little weird. So just go ahead and read it, take some time there, then we'll talk about it in a moment. Both of those are for one individual. Well, it's 100 for, it's 100 depending on how many people are. So it's kind of a weird question. I'll do it on in a minute. Yes. I think the assumption is that if there's a person in front of you, that's how much you would get out of it. Right. It's just how long it takes you to get it. However long it takes to get to the So it's kind of we're making some assumptions, and that's why we get to this here where we talk about it, even though it's probably not. For this one, what we're saying is, if, I mean, because there are going to be some times where something will take a longer time. We know on average, that person speeds out. Yeah, like 1%. So it takes, two people can. So if it takes 100 for the first person to get out of the way, another 100 for the second person to get out of the way, how long is it going to take?
Whoa.
Alright, so just to get us on the right track here. So in this scenario, there's 3 people in line. You are the third person in line. So just taking this into consideration, how long is it going to take for the first person to get out of line? 100 seconds for that first person to get out of the way. For the second person, how long is it going to take them to get out of the way? That's another 100 seconds. So by the time you get there, it should take, on average, about 200 seconds. So what we're doing here is, we're taking the expected value, the expectation here, of that first person getting out of the way, plus that second person getting out of the way. And again, we could go to the notation here, but with mean, we just add each individual mean. Each individual mean is 100. So this is 200 seconds on average. It's not so bad thing. So again, you just add up each individual mean. But now for standard deviation, we now have this. Standard deviation of the first one plus the second one. The first person plus the second person. how do we set this one up?
Is it 50/50? Or
Is it 50/50?
50 squared, 50 squared?
Alright, so we're getting somewhere here. We got the 50 squared, 50 squared. And what happens next?
And then the square root.
You got the square root. That plus. So where are we getting this equation from?
The previous example.
Previous example. It was also in our warm-up. But if we're unsure where to find it, we had to add this equation to our notes. So we started with the variance equation here when we have an addition of them. But we were able to come up with the standard deviation equation. So for standard deviation, it's all in terms of standard deviation, which is why we get that square root and standard deviation squared. It looks very similar to what you'd see with Pythagorean theorem. Just keep that in mind there. But simplifying, what should we get? We've got
50 times.
50 squared, that's
The square root of 5 times.
square root of 5,000, all right. And that's about 70 something. 70? I don't know. 70.7? How about 70.7 seconds? How far from the middle you'd expect to say or to spend? So the last thing we need to do, right?
So you did x1 plus x2, would you be able to do it?
So would we be able to do 2x? Usually we avoid that because if we were to just to put 2x, that's assuming that those two people are going to be exactly the same, but that's not always the case. Even though we have the same mean, they should be working independently. So that's the only issue.
So we can
Right, we tend to write them as separate variables. All right, so and that gets to this last part here where it's asking what assumption did we make? That assumption is related to the standard deviation rule. There's one assumption we need to make, and if we want to use this equation, what do we have to know about our two variables? They have to be what? They have to be independent. We're assuming that one person is not going to affect another person getting there. It's not going to affect their time in life. Is that always the case though?
No.
No, we made that assumption. It's probably not a good one, but that's what we did here. So we assume that a person's time in line is independent of another's. Yes.
And it's not a good assumption because, like, the different people kind of have like different issues, like as a customer, like when they're buying.
Right. Different people are gonna take different amount of times, and then that's gonna impact everybody else, right?
So like the I want to speak to the manager kind of mode.
Yeah, if somebody says something like that, then they're gonna take longer, which is gonna impact everybody else, but it didn't impact everybody before them. So that one person could be like an extreme like case. All right, so at this point, these are your notes. We're gonna go ahead and move on into another activity. Just how about a half sheet of paper? So that's all you will need. You need to share with somebody else, that's okay. So all you need is a half sheet of paper and get started there. So again, just get out your half sheet of paper, please. That's all you will need.
I don't have a nail on. I
Yeah, it has like a silver. All right, so we're gonna get started. So we're gonna go with quizzes. So for quizzes, the first one is just a warm-up one, just to get us into the swing of things. But when we get to the math one, the questions are mostly gonna be 2 minutes long. So when you get to the math one, you're gonna need to write your work on your scratch paper. And you see what you guys are trying, what you're doing. So it's not about just typing in the right answer, because if you have 2 minutes, if you're gonna have 2 minutes, that the amount that the points go down by isn't gonna go down that quickly, because you have so much time. So again, just take your time. Don't be like this person who's like going all out as fast as you can at the beginning. Take your time. Take your time. All right, so again, like we said, we'll have one just to warm up with, and then we'll do another one. So we're doing quizzes. Why, Tedesco? It's the same thing.
No, because it's not.
No, because it's not.
No, because it's not.
All right, so go ahead and log in. Make sure you put your name, please. If you're having trouble, pair up with somebody else and combine your names.